Support for Central Florida Public Media comes from the UCF College of Business, offering the new online space MBA. Designed for professionals in innovative and high-growth industries, beginning spring 2026, students gain advanced business skills through the lens of the space economy. Learn more at business.ucf.edu/space MBA.
Launching a new mission to Mars. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Brendan Byrne. NASA is sending a duo of spacecraft to Mars, calling on Blue Origin's rocket New Glenn for a ride. It's the second launch of the company's rocket. We'll speak with Ars Technica's Eric Berger about what's at stake and the future of New Glenn and Blue Origin. Then we'll take a closer look at that rocket's payload, the Escapade mission's twin spacecraft heading to Mars. The goal is studying things like how the sun affects Mars and its magnetosphere. We'll speak with University of Florida's Amy Williams about this mission and check in on other Martian missions happening right now. That's ahead on Are We There Yet? Earlier this year, Blue Origin launched its massive rocket, New Glenn, on its maiden flight off the coast of Florida. The mission was considered a success. However, the booster is designed to be reusable, but the company wasn't able to recover it. Now, Blue Origin is readying the rocket's second launch, and there are big plans if it's a success. Here to talk more about the future of New Glenn and Blue Origin's place within the commercial space industry and at NASA is Eric Berger. He's the senior space editor at Ars Technica. Eric, welcome back to Are We There Yet?
Thanks very much.
Hey, so an interesting mission launching, NASA's Escapade mission, twin spacecraft heading to Mars, launching on Blue Origin's New Glenn rocket for only its second launch. Tell us a bit about what we know about this rocket, Eric.
Well, it's a rocket that Blue Origin's been working on for at least a decade. It's a privately developed super heavy lift vehicle and would be very versatile in terms of what it can do both for commercial and government payloads. But the real challenge for Blue Origin is to get it flying regularly and start reusing it because it's a rather expensive rocket to build.
How was that first launch of New Glenn? Its inaugural launch?
Yeah, it was back in January. I think it was spectacular and a great success. The first stage performed nominally. The second stage reached orbit. You know, it's rare to see that on the first orbital vehicle launched by a private company. Obviously, Blue Origin had a lot of resources to work with, but still, I think it was a phenomenal success. They did attempt to do a landing, but they didn't get very far in that process.
That is super important to Blue Origin's business model, as you reported earlier this month in Ars Technica, right? How important is it that Blue figures out how to land that booster?
Well, it's critical in the sense that from a financial standpoint, you know, Blue Origin has been very cagey. They're a private company, so they don't have to say, but I've heard that it costs more than $100 million to build a first stage of the New Glenn rocket. Really very finely tuned vehicle intended to fly many times. And that obviously doesn't include the second stage cost. So it's the kind of thing, if you want to make an affordable launch vehicle, you know, to launch it for under $150 million, you've got to start catching first stages and reflying them.
Just how difficult is that, Eric? And I mean, you and I have talked at length about your reporting for your two books on SpaceX, which goes into great detail as to the challenges of landing a booster and how those engineers were able to overcome that challenge. But I mean, is Blue Origin facing some of those same difficulties when it comes to, you know, getting really good at landing boosters?
So it's really hard to land a rocket at sea, especially, but that's the first step. Then you have to refurbish it and then refly it once and then refly it more than once for the economics to really make sense. Now, Blue Origin has some advantages. You know, as I said, they can draw on a lot of resources from Jeff Bezos. He's invested billions and billions of dollars in the New Glenn project, and they've been able to hire well and build excellent infrastructure. You know, if you look at their landing ship Jacqueline compared to a drone ship that SpaceX uses, it's quite a bit more involved and advanced. So that's one thing. And another factor is you just got to do it. You got to do it. And they've had that one attempt, but during that first attempt, they didn't get very far. So they didn't really test the vehicle in the upper atmosphere and controlling it and coming back down to the ocean. So they will get there. I think it's just a matter of whether they get there on the next flight or flight 5 or even more than that.
The booster itself is named Never Tell Me the Odds, but you've done some reporting and you've found the odds, right? What are the odds that this is actually going to land successfully when it does launch?
I think everyone has their own view on that. The internal odds that I've heard that they're working on is a 75% chance of successfully landing the booster. For me personally, that seems really high, especially since they didn't get a lot of the atmospheric data. I think they would want, as you're controlling the flight of a rocket back to the upper atmosphere and periodically relighting the engines in a very dynamic environment, the rocket's going, basically engines first, supersonic velocity through the atmosphere. It's a pretty challenging regime to operate in, especially, on just the second flight. So I think that they're going to have to get more data before they successfully land one. So, but they're going to try, and I think that's exciting. I would put the odds at less than 50%, but fingers crossed that they succeed.
How long did it take for SpaceX to successfully land their boosters? How many launches?
Right, so they landed on their 20th flight of the Falcon 9 rocket, but it's not quite analogous because they certainly had far less resources, money, people, hardware than the Blue Origin had with New Glenn. But they sort of successfully, on their 6th flight, was the first time they really tried a powered, controlled landing into the ocean, and they were more or less successful on that flight. But if you were to use SpaceX as a model, I think you would expect Blue Origin to be successful on like the 3rd to 5th flight of New Glenn, would be my guess.
You're listening to Are We There Yet?, the radio show exploring space exploration. I'm Brendan Byrne. We're speaking with Eric Berger, senior space editor at Ars Technica, about New Glenn and Blue Origin. Aside from the financials of this, what else are folks going to be watching? This is just the second New Glenn flight. I mean, does this mission need to be successful for Blue to get different contracts? What's at stake for New Glenn 2 is what I'm asking.
Well, there's a lot at stake. As I say, the company's number one priority really is getting New Glenn flying often, and they are building a first stage. Right, this is the second one, but I don't think they have they can't pop these things out like SpaceX can pop out Falcon 9 cores. It takes a long time to build one of these. So if they want to reach any kind of a launch cadence, they need to land this one or at worst the next one to really achieve, maybe half a dozen or more launches in 2026. That's important. There's been a lot of talk about revisiting the Artemis architecture and Blue Origin, potentially playing a role in that. The reality is if they can't solve New Glenn's flight rate, and start launching their own Blue Moon landers to the moon, then I think that their role in Artemis, certainly to help get humans there this decade, is not going to really, they're not going to really be a factor, I guess. So this is job number one to solve, both for Blue Origin. It's important for NASA and Artemis as well. It's much less important for the military. It would be nice to have a third competitor to SpaceX and to United Launch Alliance, but the reality is that those two companies have been carrying the nation's spy and military satellites into space for a while and will continue to do so. The stakes are obviously huge for Jeff Bezos' other big space project, Kuiper, the satellite broadband constellation that he's building. Amazon's getting very good at building those satellites. They're just having trouble finding enough rockets to carry them into space. And so the last couple of launches have actually been on Falcon 9 rockets by their competitor, SpaceX.
You mentioned the changing Artemis architecture, and I want to talk a bit about that because you've done some reporting on that. You write in October, why did NASA's chief just shake up the agency's plan to land on the moon? How did Sean Duffy shake it up, and what does that mean for companies like SpaceX and Blue Origin?
Well, he shook it up by going on Fox News and saying that he thought SpaceX was great, but they're the reason Artemis is behind. And so they're going to look at bringing competition into the program. I don't think that means that they're going to cancel SpaceX's Starship lander. But the reality is that there are questions about whether that design is going to be ready by the end of the decade. And so I think a couple of things they're looking at very seriously. Number one is working with Blue Origin to modify its Blue Moon Mark 1 lander, which was originally designed for cargo, to maybe use a couple of those to get humans down to the lunar surface. And so that would involve, they would have to find more money essentially for Blue Origin and to help them push that plan forward. And then the other thing that they're considering, which I think is a little bonkers, Brendan, is creating a new request for information or RFI, putting it out there and having a quote government option lander. This would be basically having Lockheed or someone come in and build a lunar module-like lander, such as we used in the 1960s. And Lockheed officials have been sort of telling the Trump administration officials they can build this in 2 or 2.5 years, which I think is, if you look at kind of the last 20 years of NASA's led architecture, is insane. And probably is like a 5 to 10 year, $20 billion program. So they're looking at these things, and all of this is happening as Duffy, the acting administrator, is trying to hold on to his job. There's kind of really an interesting soup of space policy right now happening in Washington, D.C., and whether or not the United States beats China back to the moon is hanging in the balance.
Soup of space policy. I like that. It makes for some tasty stories. You mentioned China there. Is that largely the motivation behind why Duffy wants to get, these lunar landers moving faster and Artemis back on track?
I think it certainly is a motivation. I think that the president has told him that I don't want to have to congratulate China on landing on the moon before we get humans back there. And Duffy has, it's interesting, in the last several weeks, he's switched from being a cheerleader saying, there's no way we're going to lose to China, blah, 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 to sort of turning around saying, well, actually, if we don't look at this problem pretty hard and find some solutions, it could happen. So I think that's certainly driving it. We don't really know how well China is progressing toward its goal of landing on the moon before 2030, in their words, but they certainly have their hardware, the rocket, the lander, the spacecraft are all making, pretty good progress and have had some important tests recently. So I think you could characterize them as ahead of the United States right now, unless NASA changes its plan or puts more emphasis on it. I think there are things that NASA could do to incentivize SpaceX and Blue Origin to go faster that they just haven't been. It's really kind of been a lost year in terms of space policy in the Artemis program.
Finally, Eric, you mentioned Acting Administrator Sean Duffy's trying to hold on to his position. Is there any competition in the wings? What does he need to worry about?
Well, he was brought in as the acting administrator back in June, or I think it was early July, after Jared Isaacman was basically bumped, the former nominee, for political reasons. But since then, and so when Trump appointed him, I think it was with the expectation that he would sort of start interviewing people and help find someone to replace him. So he has not done that. He has not, I don't think, really conducted very many, if any, interviews at all. And my understanding is that the president called him and told him to re-interview Isaacman. There's been a lot of people in Jared Isaacman. This is the private astronaut who flew on the Polaris mission and is a billionaire financial executive who's pretty broadly liked, I think, in the space community. But Isaacman, there's been a lot of support for him rebuilding, and so it actually is a competition now. Jared has been at dinner at the White House, Mar-a-Lago, met with the president quite a bit frequently. Duffy was just back in the White House last week, sort of pressing his case. And it's clear Duffy wants to hold on to the job. He likes the publicity that NASA gets. But there's the people who would like to see an administrator who more deeply understands the problems with Artemis and NASA and probably would have more time to fix it, have been pushing for Isaacman. And it's really down to what the president decides to do, and hopefully he'll make a decision the next week or so.
Always interesting storylines on the Space Beat. Glad we have you to break them down. Eric Berger is the senior space editor at Ars Technica. Eric, thanks for joining us.
My pleasure, Brendan. Thank you.
Still to come, New Glenn's interplanetary payload, the twin mission to Mars.
All of this is really helpful for us to understand sort of the billions of years of impact that solar winds have had on the planet, and what that means for the potential for life to have survived if it was ever present on Mars.
What this new mission may find, and an update on Martian missions in progress. That's ahead on Are We There Yet?
Support for Central Florida Public Media comes from the UCF College of Business, offering the new online space MBA. Designed for professionals in innovative and high-growth industries, beginning spring 2026, students gain advanced business skills through the lens of the space economy. Learn more at business.ucf.edu/space-MBA.
You're listening to Are We There Yet?, the radio show exploring space exploration from Central Florida Public Media. I'm Brendan Byrne. How do we study the moon and Mars, and how humans might live there? Well, one way is with analog missions, or environments that mimic extreme space conditions or even other planets here on Earth. Just last month, hundreds of volunteers gathered to perform the world's largest analog mission. It spanned over 16 different habitats, all to prepare for humanity's future in space, including missions to the moon and Mars. We talk about the world's biggest analog mission. That's next week on Are We There Yet? But for now, we're talking about two twin spacecraft that are catching a ride on Blue Origin's giant rocket, New Glenn. The Escapade mission will launch to the Red Planet and study how things like space weather impact Mars. Plus, the data gathered from these spacecraft could help scientists get closer to finding signs of ancient life on the planet. Here to talk more about this Mars mission and check in with other rovers that are roaming the Martian surface is Amy Williams. She's an astrobiologist and associate professor at the University of Florida. Amy, welcome back to Are We There Yet?
Thanks so much for having me back.
Hey, it's good to have you back. And we're going to start off the planet. We usually talk about what's going on the surface of Mars, but there's a launch of a duo of satellites that's going to be looking at what is not on the surface of the planet, right? Escapade, tell us a bit about what this mission entails.
So number one, Escapade is Escape and Plasma Acceleration and Dynamics Explorers. So
Sounds so cool.
Yeah, I know, it's really cool. And it's just another awesome example of potentially, I would imagine, coming up with an acronym and then fitting words to it. But it totally encompasses what the mission is meant to do. So yep, it's twin orbiters this time, and they're going to be, of course, orbiting Mars. And this is a cool way of sending missions to Mars because, like, as I'm sure your listeners are aware, it is expensive to launch and launch and launch. And so Escapade came through originally as a simplex mission. And again, it's another one where there's an acronym that goes with the word. But if you think about the core of simplex, it's simple. It's a low-cost way of sending planetary missions, often with a ride-along or ride-share. And so Escapade was actually originally going to ride-share with the Psyche launch. And Psyche ended up doing, instead of like a slower sort of orbit, kind of using Mars as a gravity assist, it ended up doing it really fast. And that's not really good if you want to eject some satellites and have them start orbiting Mars. So they had to move to a different platform. And so they're actually scheduled to launch on the Blue Origin New Glenn launch with a no earlier than launch date of November 9th. So yeah, we'll see what happens. I always cross my fingers with launches. I am not an engineer or a rocket scientist. So it's obviously driven by physics and mathematics. And to me, it's just a little bit of magic and luck.
Yes,
yeah.
Certainly. So, Amy, what is Escapade going to be looking at when it gets to Mars?
So there are these dual orbiters that are actually exploring information about the magnetosphere of Mars and sort of the way that solar wind has winnowed away the atmosphere without a strong magnetic field. So and again, this is getting into a realm of sort of the space physics, space science that I am way less familiar with, but need to catch up on because Mars. I want to learn everything about Mars on the planet and the atmosphere and the exosphere as much as possible. So the orbiters are actually meant to get into sort of a sequence where they can kind of process past each other as they're moving around Mars in their orbit. And this is actually going to enable them to make these really cool measurements about the magnetic field around Mars, electrostatic analysis of suprathermal ions, which I assume have to do with the solar wind, and a Langmuir probe, which is useful for measuring thermal electron density.
You mentioned you want to learn everything about Mars, right? Mars. Is the data and the findings from this mission, is there a chance that it can help you with your work down on the surface and uncovering the possibilities of ancient life on Mars? Is this going to give you a better snapshot of what you're looking for?
Every data point is helpful. Absolutely. So it's just really useful in thinking about how the solar wind has interacted with Mars, and that, this is the loss of the magnetic field around Mars is why the atmosphere was winnowed away, why you have such low atmospheric density. Water is not stable at the triple point where it could be solid, liquid, or gas the way that it is on Earth. So really the loss of that magnetic field and the impact on the atmosphere is core to why Mars is this inhospitable place today. So yes, I think that any information that's returned about understanding the processes that control Mars's, magnetosphere, how ions flow around the planet. All of this is really helpful for us to understand sort of the billions of years of impact that solar winds have had on the planet, and what that means for the potential for life to have survived if it was ever present on Mars, and if it's there, could it be in the subsurface, kind of surviving from the radiation environment. So it all feeds into kind of understanding what I love to talk about, which is the exploration of looking for life beyond Earth.
You're listening to Are We There Yet from Central Florida Public Media. I'm Brendan Byrne. We're speaking with Amy Williams. She's an associate professor at the University of Florida and an astrobiologist. We're talking about missions at Mars. Amy, let's go to what you are more familiar with, and those are the rovers that are on the surface of the planet. What is new with Perseverance? Let's start there.
So Percy is still exploring outside of Jezero crater where we originally landed. We've been exploring this area along the crater rim that looks like it's made of chunks of blocks that maybe came from, one of the big impacts from very, very early on. So maybe something that formed the Jezero crater, or maybe something that formed the even bigger Isidis impact, which is what we're on the edge of in Jezero. And so, we don't know exactly where these materials came from, but they're sort of these, what we call like breccias. Not everywhere we've explored, but actually one area in particular that we've been interested in. And a breccia is a rock made of pieces of other rock. And the pieces are very angular and fragmented. And if you imagine, if you have an impact and it hits the surface of a planet, it's going to eject these chunks of rock. Those can get sort of embedded in the ground mass and kind of become their own rock called a breccia. And so we're really interested in exploring these kinds of rocks because it's telling us about very early crust on Mars, what it was like. And it tells us a lot about how the planet evolved, as a rocky body. And so it's really cool to be sort of looking back so far in time to these rocks that are preserved on the crater rim. And so, Percy's been exploring these different blocks, been looking at these really neat, potentially impact breccias, kind of exploring what was Mars like very, very early on.
I'm looking at images of them now. They kind of look like a fruitcake almost, with like different pieces of rock inside, don't they? Yeah.
That's a great way to think about it. Absolutely. There are these, it's like an inclusion, basically, a chunk of rock within a bigger rock.
So essentially this impact happened and just combined all of these different materials together, and you can kind of parse out which ones they are and where they came from.
If you're lucky, you can parse out which ones came from where. That's been part of the challenge because there's, we're getting as much context as we can, but every block we visit is a little bit different. And so we're still trying to understand the sort of the breadth of diversity of rocks in this sort of jumbled up crater rim area.
Fascinating to look at. Is this rare to find on the surface of Mars?
Trying to put this in context of it's exactly what you would expect in an area that's experienced a bunch of impacts. I'm trying to think if we've seen an impact breccia before. Maybe not to my knowledge, but that does not mean that we have not seen one before. So once we've gotten out of sort of the sedimentary layers within the crater, we're getting into the realm of rocks that I don't normally get to play with. So this is certainly a special rock, even if we've seen impact breccias before, because the diversity that we see just in those little snapshots are really incredible. But there's also cool stuff going on with Curiosity. I never want to leave out my other rover friend. So Curiosity has been ascending Mount Sharp for years now, and we finally arrived at this area called the Boxwork. We've seen this from orbit. It was sort of almost like a dream to be able to climb as high as we have to get to these really cool rocks that you can see from orbit. And it's potentially a way to actually see into the ancient subsurface, like an ancient groundwater controlled environment. So the boxwork, it actually looks like several boxes kind of stacked side to side, and it forms when you have water flowing through sort of these subterranean conduits, sort of the way that groundwater flows on Earth, of course. And it looks like actually those conduits were sort of cemented in place by that groundwater flow. And then whatever was in sort of the intermediate areas, sort of the inside of the box, as has been exposed on Mars, been kind of weathered away. So you actually have sort of these little divots and then these raised ridges, and they form sort of this boxwork structure. And so we are finally, we've been exploring this area, finally trying to drill into some of these materials. Finding bedrock that's big enough to drill into is often a challenge. So we've had the opportunity to kind of explore this ancient groundwater system, which is something that we really haven't gotten to explore in detail like this previously.
Very cool. What do you hope to learn from it?
So there's this excitement that, you're finally getting into the subsurface, into a place that we know that water was flowing. And this must have been deep. I mean, I don't have a constraint on how deep, but deep enough down that you're basically looking at a subsurface habitable environment in the ancient past. We know Gale Crater was kind of filled up with sediments, so we do say that a lot about some of these were subsurface, but this is like this large scale area that was clearly influenced by groundwater. And so it's sort of a new taphonomic window, a way to look into the rocks and say, all right, could life have been here? Could it be preserved in these rocks? And it's giving us, even if there isn't evidence for life, of course, because Curiosity is not a life detection mission, but it gives us insight into a habitable environment that we've never been able to explore with this mission before.
That is so cool. Finally, Amy, we know that the U.S. government is shut down. NASA is part of the federal government and does run these rovers. Have there been any impacts to these missions due to the U.S. government shutdown?
So there have been some impacts in that many civil servants work on the missions. And so when the government is shut down, they are not allowed to work. So many of us who are not federal employees are stepping in to fill those roles while they're out. And so it does kind of stress everyone's bandwidth, because there are just fewer people doing the jobs that still have to be done every day. And then, as far as funding goes, at least Curiosity and Perseverance are operated by the Jet Propulsion Lab, which is in Pasadena, and JPL is operated by Caltech. And so it's actually a contract to JPL to run the missions as they are right now. So there's still funding right now on those contracts supporting the missions, but, contracts need to be renewed. And so, we're all kind of holding our breath, waiting to see what's going to happen next if we can hopefully get things resolved enough to support what everybody needs with the government reopening. And part of that, of course, includes the rover missions.
Well, luckily, Perseverance and Curiosity are both patient when it comes to exploration, right?
Yes.
Excellent. We've been chatting with Amy Williams. She is an astrobiologist and associate professor at the University of Florida. Amy, thanks so much for joining us.
Thank you.
That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, or really wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. And if you got an idea for a future episode of the show, or you want to join us as a guest, email us. We're arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our intern is Orion Boone. Our producer is Marian Summerall. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.